Let's look at the problem number 39, test 2. The topic is fluid mechanics, basically the statics part. Okay, so what is given is an object floats in water such that 9 by 10th of the object is submerged. This is water and this is the solid object. Okay, 9 by 10th of it is submerged, so this is total is L. So this will be 9L by 10. Okay, so this is my displaced volume of water by the object. So the water is basically this area. Okay, so what is asked is the density of this object is asked. So let the density of the object be rho naught. Density of water is rho W, which is 1000 kg per meter cube. Okay, so let's draw the free body diagram of this object. So what are the forces? One force is the weight of the solid object. The other force, which is acting at the CG of the displaced volume, is the buoyancy force FB. So these are the two forces. Now in equilibrium, if you take this as my y and this is my coordinate axis, so in equilibrium sigma Fy is 0. All the forces acting on the body should be 0. So let's take positive direction. So W is positive minus the buoyancy force is upward. Only these two forces are there. So the weight has to be equal to the buoyancy forces. Okay, so this is the thing. So now what is the buoyancy force? How do I compute it? The buoyancy force is nothing but it's the weight of the fluid, which is the water in this case, displaced. The weight of the fluid displaced means it's basically the density of the fluid into the volume of the fluid displaced into G. So this part is the mass, and when you multiply with G, it is the weight of the fluid displaced. So this is, let's keep the density as rho W. The displaced volume is nothing but this length, because it's a cube, so this length, and the cross section will be again A. So the volume will be basically area of cross section into the length. Okay, so this is my displaced volume. So it's ultimately how much water can fill in this displaced volume, and the weight of that water is nothing but the weight of the fluid that is displaced by this solid. Okay, so area of cross section, because it's a cube, if you look at from the side view, this area of cross section will be my L square into G. So this is my buoyancy force. Now weight of the solid, just apply the same in the same fashion. The weight of the solid will be the mass of the solid into G. Mass of the solid will be rho naught into the volume of the solid, which is L cube, because it's a cube. So now just using the equation 1, which is this, so ultimately we need to find out rho cube and rho W into L square into 9L by 10 into G. So I'm using this entire thing over here using equation 1. Okay, so ultimately I'll get rho naught, which is rho W into 9 by 10. Rho naught, density of water 1000. This is pretty known. So it's 900 kg per meter cube. Let's see whether we have this in the option or not. 900, option D. Thanks.